Well, in this question, they have given this sector, a circle inside this sector, and then they have shared the upper part of the sector. And this radius is r, and this angle is theta. Find CD in terms of r and sine theta. That is the first part of the question. CD is this line from here, C to D. All right. So if FO is radius of this circle, OD will also be the radius of circle. So OD is known to us. Only problem is to find CO. Okay. So to find CO, let's look at this right angle triangle. But nowhere have they shown any right angle. But we know that the tangent to a circle and its radius always make a right angle, 90 degree. That's why I took this as a right angle triangle. Let me draw it somewhere here. So this is R, this angle is theta, this corner is C, this is O, and this is F. I have rotated the drawing by a little bit so that it becomes easier. Now we can see here that sine theta is opposite over hypotenuse. Opposite in this case to the theta is R, and hypotenuse is CO. That's what we were trying to find out, right? So sine theta equal to R over CO. So let's cross multiply. Sine theta will become denominator here, and CO will be going to the other side. So CO equal to R over sine theta. And now we know CD is CO plus OD. CO we just found out, which is R over sine theta. And OD is already known to us, R. So we found it. CD in terms of R and sine theta. That's what the question was. Next part. It is now given that R is 4. Okay, R is 4. And theta is pi by 6. Okay. Find the perimeter of the sector CAB. Okay. CAB means the whole sector. CAB. Alright. So since it is given now that R is 4, this R is 4, and sine theta, theta is pi by 6. So we know that CD is also the radius, CA is also the radius, and CB is also the radius of the same sector. So we can write it here. Let me do it here. CA equal to CD equal to CB equal to the radius. I'm writing capital R because it is different from this R. Okay. Since CA and CB are part of the perimeter of the sector, we will use both of them in terms of CD now. CD, we already know CD is this. So let's put R equal to 4 and theta equal to pi by 6 in this. And what is CD then? CD becomes R 4 over sine pi by 6 plus 4. Okay, 4 divided by half, 0.5 rather. Okay, plus 4, which is 8 plus 4 equal 12 centimeters. So CA, CB both are 12 centimeters. So we know this side and this side. Only thing left is the arc. And the arc length is, this is the formula for arc length. If you look at the formula, so we'll do that now. Arc AB equal to R theta. Okay, R is how much? 12 centimeter. We know this is the radius now of the bigger sector. Theta is not pi by 6. Theta is double of the pi by 6 because this is the angle subtended by the arc on the center C. So pi by 3, double of pi by 6. So 2 times pi by 6, which will be pi by 3 actually. So this is arc. So let's cancel out 6 times 2 is 12. So that is 4 pi. So now perimeter, which is let me write here CB and CA. Yeah, CA plus CB plus arc AB. CA we found out was 12. CB is also 12. Both are equal to CD, which we found here. And 4 pi is the arc AB. So the perimeter finally becomes 24 plus 4 pi. Alright, what is the last part? Find the area of the shaded part in terms of pi and square root 3. This shaded part. If we take the whole sector, this whole sector, and subtract circle from it, we'll get the shaded part, but we'll also get these two parts which are difficult to find out. So that will not help. So we have to do something else. Let's do it here. Let's find the area of this triangle, which is, I've just drawn it here. Same will be the area of the second triangle here. This will be a kite kind of. Okay, so I will double the area of this triangle. I'll get the area of the both triangles. Okay, from that I will subtract the area of this sector. So I will be left with the shaded part. This is the plan, and we will find the area of the right angle triangle first. Okay, the right angle triangle is in front of us here. Okay, so the area of the triangle I can use, yeah, it's a right angle triangle, so I can use height half times base times height. Okay, base we know is 4 centimeter, height we don't know, so let's find height first. Let's call it h. Okay, so we can find it here. So r is the opposite, right? So we can write tan pi by 6 will be opposite 4 over unknown h. So let's cross. First, tan pi by 6 is 1 over square root 3. 4 over h. So h goes here, equal to 4 square root 3 by cross multiplication. We got height. So let's write here. The area of one of the triangles is half times base is 4, and height now we got is 4 square root 3. This can cancel with this. So 8 square root 3 is the area of one triangle, but we wanted to find the areas of two triangles. This one also, this one, COE. So we have to double it. So area of the kite, which is the two triangles, will be 2 times 8 square root 3, which is 16 square root 3. Now we have to find the area of the sector, this sector. Okay, so do we know one of the angles? Yes, we know this angle because this is pi by 6, this is pi by 2, so remaining will be pi by 3. Okay, let me show the calculation somewhere. Let me show it here. So one angle of the triangle was pi by 6, one was pi by 2, which is 90 degree, and then the third one is unknown, and we know the sum of all the angles of a triangle is pi. So x equal to pi minus pi by 6 plus pi by 2. And if you use your calculator, you will get it as pi by 3. So we got angle as pi by 3. So this is also pi by 3, the second one. So total angle for the sector we were trying to find out the area of is 2 pi by 3. And we know the radius is r, which is 4 centimeters. So the area of a sector is here. This is the formula, and we'll use it. So area of the sector will be half theta. Theta we just got it, pi 2 pi over 3, and r square. R is 4. So this 2 and this 2 will cancel out. So we will be left with what? 4 square, 16 pi over 3. And the area of the shaded region is clear to us now. This area of the kite minus area of the sector, which is 16 square root 3 minus 16 pi over 3. And that is in terms of pi and square root 3. Yeah. Well, in this question, we have to express the shaded area in terms of r and theta, where r is the radius of this particular sector and theta is its angle at the corner A. And we can find this area of the shaded part. How? We'll find the area of the triangle ABC, and from that, if we subtract this white part of the sector, we'll get the area of the shaded part, and that we have to express in terms of r and theta. So let's focus on the area of the triangle ABC. What is the area of a triangle? Let's write it here again. Half BC sine A, where A is the angle made by the sides B and C. Alright, so two sides we know here in this triangle, R and R, but we don't know the angle between them, right? But we can find it. How? We know the three angles of a triangle, they add up to 180 degrees, which is pi in radians. So if this is theta, this has to be theta. This angle has to be theta as well. Why? Because this R and this R makes it isosceles triangle, and the base angles of isosceles triangles are equal. That means we can find this angle we need in terms of theta. So theta plus angle B equal to pi. So angle B becomes pi minus 2 theta. So we'll find the area of the triangle now using this formula. So it will be area of triangle equal to half BC. B is R, C is also R, and the angle between them now is pi minus 2 theta. So it becomes half R square, and if you remember the quadrants, in second quadrant, which is pi minus 2 theta, we don't know theta yet, okay? So pi minus 2 theta in this quadrant, sign is positive, right? So basically this angle is 2 theta and this angle is sine pi, this is pi minus 2 theta. So sine pi minus 2 theta is actually sine 2 theta, because in second quadrant sine is equal to the acute angle in that quadrant and it is positive, so no change. So pi is gone. Now we can write it as just 2 theta. This is the area of the triangle. Let's find the area of the sector now, and area of the sector is, the formula is, sorry, here, so minus half r is r, so r square, and theta is theta. Let's take half r square common, so we'll be left with sine 2 theta minus theta. This is the area of the shaded region in terms of r and theta. Let's go to the second part. In case where r is 10 and theta is 0.6, find the perimeter of the shaded region. Okay, so we have to find the perimeter of the shaded region. So do we know this? No, we don't know. Do we know this arc? No, we don't know. Yes, we know only this. All right. So the perimeter will be DC line segment and line segment BC and arc DB. Okay. So it will be DC plus BC plus arc DB. That will be the perimeter. Okay, BC is known to us. The line BC is 10 centimeter, right? Yeah, it is known to us 10. Arc DB is easy to find out. Let's find it. Arc DB will be, this is the formula for arc. R theta. So R theta. R is 10, theta is 0.6. Now only challenge is the DC. DC is not known to us. So how can we find DC? All right, this is 10. That means AD is also 10. If somehow I find AC and subtract 10 from it, I will get DC, right? So that becomes a new challenge for us, and that's what we will do. There's a triangle here. In triangle, two sides are known, 10 and 10, and we know this angle between them is pi minus 2 theta, right? So we can use cosine rule to find the third side. Okay, let's do that. So I'll use cosine rule here. We have a triangle where we have this side as 10, this side as 10, this angle is pi minus 2 theta, and we have to find this side. Let's call it A. All right, and the cosine rule is a square equal to b square plus c square minus 2bc cos A. The side A and angle are opposite, so this angle will be used at capital A, and this A will be used at unknown side. B and C are the R's, which are 10 in this case. All right, so let's use it. A square equal to 10 square plus 10 square minus 2 times 10 times 10 cos pi minus 2 times theta. Theta is 0.6 they have given, so that is 1.2. Okay, so let's directly do it this way. Square root both sides. So A becomes square root 200. This is 100, this is 100, 200, minus this will also be 200 cos pi minus 1.2. When I use my calculator, I got 16.5 units. Okay, so I know 16.5 now. So let's go back to the original question. So this is 16.5. I reduce 10 from it, so remaining DC is 6.5. Okay, so 6.5 is the one I will use here. 6.5. So that becomes the perimeter now. So perimeter is 6.5 plus 10 is 16.5, and this is 0.6, so 6. Perimeter will be 22.5 centimeter. In this question, they have given two sectors. So let me show you the first sector with this. This is the first sector with this angle, this arc, and this radius 8 centimeters. Okay. Now the second sector will be this one with this angle, this radius, and this arc. Okay, and this is the one we will use in this as far as I know. Okay, so they're saying find the angle BAO. BAO is this angle. Okay, in this triangle we know all three sides, 12 centimeters, 8 centimeters, and 8 centimeters. They have been helpful by giving all three sides to us, because this was not needed, because radius is 8 centimeter. If we know it, then the other one will be 8 centimeter, but they have given very good. So when we have all three sides of a triangle and we want to find one of the angles, we can use cosine rule. Okay, and let me again write cosine rule, which we used in one of the questions earlier. A square equal to b square plus c square minus 2bc cos A. This is the angle we want to find, and coincidentally A is the name of the corner where we want to find angle. So this angle we need to find, but this side A should be the opposite side to this angle, which is this 8 centimeter line BO. This is smaller A, so it will be 8 square here. B and C are the rest of the two sides in any order, doesn't matter. 12 square plus 8 square minus 2 times 12 times 8 cos A. So we know everything except for the angle A. And now we can bring these two to the other side. 8 square is 64 minus 144 is the square of 12 minus 64 is the square of 8. And this will remain here. 12 times 2 is 24 times 2 is 192 cos A. Okay, 64 and 64 will get cancelled out, so we are left with minus 144. Let's divide both sides by minus 192. Minus 192, so that we get rid of this one. So A becomes cos inverse minus 144 over minus 192. Both cancel out and we get angle as 0.723 radians. Next part, find the area of the shaded region. We have to find the area of the shaded region. In this case, let's focus on this sector, yeah, and out of this sector, if we remove this triangle, we'll be left with the shaded part. So basically, to find that shaded area, we have to find the area of the sector BAC, and we have to subtract the area of the triangle BAO. This will be the area of the shaded region. This is the second part. All right, so let's find the area of the sector first, and we have been given the formula here. I have copied it from the formula sheet again. So half r squared theta. R is, for this sector, R is 12, and angle we just found out 0.723 radians. So it will be half theta is 0.723 and r square will be 12 square. Now, area of the triangle BAO. So we also know the area of the triangle is half BC sine A. So B and C are the two sides around the angle A. Angle A is known to us, this one. By chance the name is A here. If it was some other alphabet, that would be used. So yeah, we know 8 and 12 are B and C, and the angle is 0.723. We just got it. So it will be half 12 times 8 sine 0.723. And we can put the whole of it in our calculator. We get 20.3 centimeter square. That's the answer of part 2. What about part 3? Part 3, they said, right, find the perimeter of the shaded region again. All right, so this time it's perimeter. So to find the perimeter, we should know what we have to add. Some of them we already know. This is one of the lines around the shaded part. So 8 centimeter is one of the sides. This is known to us because this is 8. The total is 12 because this is also the radius like this for the sector. So we know this is 4 centimeter now. 8 plus 4 will be 12. This is 4 centimeters. So 8 and 4 known to us. Only thing required is arc. And for arc, we have this formula here, right here. So r theta. R is 12 again. Theta is again known to us 0.723. And we'll do it. So we need to find perimeter 8 plus 4 plus arc. Okay. So the perimeter equal to 8 plus 4 plus r theta. Arc is r theta. R is 12. Theta is 0.723. That's simple. And if I add them, it will be about 20.7 centimeters. One line and it's done. Here the first part of this question is just 1 mark worth. That means it will be the easiest one. They're asking us to show that the radius of the larger circle in this picture is r square root 2, where r is the radius of the smaller circle. Can you see here? So if this is r, that means this is also r. That means this is also r. That means this is also r, because all 4 are from center to the circumference. They are r. Okay? And if I join B and C, and if I join BC, don't you think this BC is the radius of the larger circle? And that's what we have to prove, equal to r square 2. So in the triangle CBA, we will use Pythagorean theorem. which is CB square equal to R square plus R square. So CB square equal to 2R square. If we square root both sides, CB is equal to square root 2R, which can also be written as R square root 2, and that's what they wanted. B part, find the area of the shaded region in terms of R. This is the shaded region, and we have to find its area in terms of R. So we can find easily this area of this semicircle in terms of R. Yes? If somehow we remove this white part from that semicircle, we'll get the area, shaded area in terms of R. But the challenge will be to find the area of this white part. Okay? And let me write that first. Area of the shaded part equal to the area of the semicircle, which is CEDA. CEDA minus area of the minor segment, and let's call it M here, CMDA, right? And this segment is the challenge. We'll try to find it out now. So let me draw what? Let me draw a circle which is the larger one. Okay, let's draw it here. Okay, so now we know the center of this circle is here. Its radius is R square root 2. Radius here will also be R square root 2, and this is a chord, and this is what we are interested in, to find the area of this segment so that we can substitute it here, and we'll find the area of the shaded part. Let's see what is the angle. We are not given any angle here. So we have to find this angle first. That will be easier part, I think, because we know this is R. So tan, let's call it theta. Tan theta equal to R over R, opposite over adjacent, which is 1. Theta equal to tan inverse 1, which is pi by 4. So we know the angle now. Alright, so this will be pi by 2. Why? Because pi by 4 is the half the angle. This we want whole this one. So pi by 4 multiplied by 2 will be pi by 2, and that's the angle I'm going to use. Okay, now we need to, our focus is to find this area. So this area here, area of segment, will be area of the sector. Let me show you clearly which sector I'm talking about. I'm talking about this sector. And if I subtract the area of the triangle, this triangle from a sector, I'll be left with the area of the segment. So area of triangle. Okay, so now area of the sector, we have the formula half theta. Theta is pi by 2. R square, R is R square root 2, minus area of the triangle is also known to us, half BC. B is R square root 2 here, and R square root again, C also, both of them are R square root 2, and the angle between them is pi by 2, sine pi by 2. Alright, so it becomes 2 and 2, 4. So pi by 4 and R square times 2. Yeah, R square will be R square, square root 2 square will be complete 2. They cancel out. So we left with pi R square over 2 here. Alright, now the second part, half R, again this will be R2. Okay, R square times 2 over 2. Sine pi by 2 is 1. Okay, 2 and 2 cancel. So pi R square 2 minus R square is the area of the required segment. Let's go back to our original one. Area of the semicircle. What is the area of the semicircle? The area of a circle is pi r square, correct? And we are talking about the smaller circle this time. Pi r square, yeah. And semicircle will divide by 2. Minus segment. Segment in terms of r, we just got it. Pi r square over 2 minus r square. Pi r square over 2 minus r square. So it will be what? Pi r square over 2 minus pi r square over 2 plus r square. And both cancel out. Answer is just r square.